Welcome to The Explainer. Today we're going to break down a pretty wild new paper that gives us a mathematical blueprint for teamwork. Basically, a physics for how any two minds, and that includes human or AI, can actually work together.
So let's start with something we've all felt, right? You've been on a team where everything just clicks. It's like magic. The ideas flow and you get so much done. And then there's the other kind, the team where every single conversation is a struggle. It's just a total grind.
But what if I told you it's not about magic or luck or some mysterious chemistry? What if it's actually just science? Well, that's exactly what this paper, The General Theory of Interintelligence Collaboration, is all about. It argues that there are fundamental, almost mathematical rules that decide whether a team flies or flops.
Okay, so to really get this, we've got to learn the lingo first. The theory boils any collaboration down to four essential parts. Think of them as the basic Lego bricks for building a team.
First up, you have the node. Now it sounds a little technical, but it's super simple. A node is just any thinking thing in the system. It could be you, your coworker, or, and this is really important, it could be an AI. It's just a little self-contained processing unit. Of course, a node can't run on nothing. It needs fuel, and that fuel is called the substrate. For you and me, that's our physical energy, our focus, maybe how much coffee we've had. For an AI, it's things like processing power and memory. The point is, it's the limited resource that makes the thinking happen. It's the fuel in the tank.
So you have two nodes? How do they actually team up? That happens through the edge. The edge is the bridge that connects them. It could be a conversation, a shared Google Doc, an email chain, whatever it is that lets two separate minds link up and start acting like one bigger brain.
And finally, every node has a vector. This one might feel like it's straight out of high school physics, but the idea is simple. The vector just shows which way a node is pushing and how hard it's pushing. The direction is the goal, and the size, or magnitude, well, that's how much effort is being put in.
So there you have it. Those are the four building blocks. You've got the thinkers, the nodes, the fuel they run on, the substrate, the connection between them, the edge, and the direction they're headed, the vector. The really cool thing is, the theory says with just these four ideas, you can describe pretty much any collaboration you can think of.
All right, we've got the pieces. Now, let's talk about the rules of the game. See, this isn't just a list of definitions. The theory is built on three fundamental axioms, unbreakable laws that are like the laws of gravity for teamwork. You just can't get around them.
And these laws are really intuitive when you think about it. First, the law of substrate finitude. You can't run on empty. Simple. Everyone's got a limited tank of energy. Second, the law of fractal continuity. This just means your communication style has to be compatible with your thinking style. The external link has to match the internal process or it'll just break. And third, the law of vector directionality. If two people are pulling in opposite directions, well, they're not going anywhere, are they? They're just wasting energy. These aren't suggestions, they're the ground rules.
Okay, this is where it gets really, really cool. All those pieces and rules we just talked about, they all come together into one powerful equation. A formula that can literally calculate the value that any team creates or destroys.
I know. It looks like a bunch of math. But trust me, the story it tells is incredibly simple. It basically says that the value a team creates is your total potential multiplied by how aligned you are, minus all the real-world costs of working together. Let's walk through it step by step.
The first part is just simple addition. You take the raw talent and capacity of node A, add it to node B, and boom, that's your team's total potential value. This is the absolute best case scenario, what you could achieve in a perfect world where everything goes right.
But, and this is a huge but, that potential gets hit by your alignment. That's the cosine of the angle between your vectors. If you are perfectly aligned, pushing the exact same direction, you get to keep 100% of that value. But if you're in total opposition, you're multiplying by -1. Think about that for a second. You're not just failing to create value, you are actively destroying it.
And finally, you have to subtract the inevitable costs of teamwork. Nothing's free. First, there's the coordination cost. That's all the time and energy spent on meetings, emails, status updates, just keeping the whole thing running. And then there's friction. That's the messy human stuff, the misunderstandings, the bruised egos, the arguments. All of that gets taken out of your final value.
So, the theory is great at explaining success. But honestly, what I think is even more powerful is how clearly it predicts failure. It identifies four classic ways that teams don't just struggle, they completely implode. The paper calls them the four horsemen of collaboration collapse.
First is vector cancellation. We just saw it in the equation. You're working at cross purposes, actively destroying value. Second is substrate depletion. This is burnout, plain and simple. One node is just draining the energy from the other. Third, access failure. Information gets stuck in silos, maybe there's no trust or the communication line is bad, but you can't get the info you need. And finally, loop divergence. This is when feedback arrives so late that it's completely useless. You're trying to steer the ship, but you're looking at a map from last week.
So this is all fascinating, but what's the takeaway? What do we actually do with all this? Well, the paper doesn't just diagnose the problem. It also proposes a practical solution designed to stop those four horsemen in their tracks.
It's called the Intelligence Collaboration Handshake Protocol. Yeah, it's a bit of a mouthful, so we'll just call it the ICHP. The best way to think of it is as a pre-flight checklist for teamwork. Before you start a project, you run through this protocol to make sure you're actually set up to succeed.
And this quote from the paper really gets to the heart of it. It says, a good protocol has to make it easy to ask low-cost queries. So what does that mean? It means creating an environment where it's cheap and safe to say, wait, I don't understand, or can you explain that again? It's all about making it easy to access what the other person knows that you don't. A good handshake makes asking for help a feature, not a bug.
And this is where it all leads to a really mind-bending place. Because this whole framework, it's not just for human teams. It gives us a formal mathematical language to design the future of collaboration between people and AI. Suddenly, we have the right questions to ask. How do we build the best edge to communicate with an AI? What are its substrate limits? How do we guarantee our vectors are perfectly aligned? And that leaves us with one heck of a final thought. Are we ready to design the handshake for a future where our most important teammate isn't human at all?